Hi, welcome to Data Structures and Algorithm video series from 10xcoder.com. In this video, we will discuss bitwise operators and interview questions related to them. Before talking about bitwise operators, let's do a quick refresher on representing numbers in memory. Here by memory, I mean RAM. Every major programming language divides the numbers into two major categories. One is unsigned numbers and the other category is signed numbers. In unsigned numbers, we have 0 and all positive numbers. Most modern computers use a binary number system to represent unsigned numbers. For example, decimal number 2 is represented as 0010 as a 4-bit binary number. So if you had a 32-bit computer, the decimal number 2 would be represented as 10 prefixed by 30 zeros. On the other hand, we have signed numbers, which consist of all negative numbers, 0 and positive numbers. To represent 0 and positive numbers, we use a similar binary representation that we use for unsigned numbers. In order to represent negative numbers, we use a technique known as 2's complement. 2's complement simply means we convert the number into binary form, flip or invert all its bits, and add 1 to it to get a number that would represent a negative number. For example, to represent negative 2, we start by converting 2 into binary. We get 0010. Then we flip all the bits in the binary number and we get 1101. At last, we add 1 to the number and we get 1110. So the binary number 1110 represents negative 2. If you had a 32-bit computer, then applying the 2's complement process, that is flipping all the bits and adding 1, we would end up with 10 prefixed by 30 ones. This would also represent negative 2 just as 1110 before. Now an important question arises: when a computer sees some bits, how does it know whether to interpret those bits as signed or unsigned numbers? Well, to avoid this confusion altogether, some languages like Java and Python don't have a concept of unsigned numbers. That is, they treat all the numbers as signed numbers. Whereas some languages like C and C++ allow you to define unsigned numbers explicitly using the unsigned keyword. When looking at a signed number, the computer can tell if the number is negative or positive just by looking at the first bit, which is also known as the sign bit. If the sign bit is 1, then the number is negative. Else if the sign bit is 0, then the number is positive. This pattern in the first bit arises due to mathematical details hiding in the 2's complement technique. Now we know about memory representation of numbers. Let's have a look at the bitwise operators. There are 6 well-known bitwise operators: bitwise AND, bitwise OR, bitwise XOR, bitwise NOT, right shift, and left shift operator. All of these except bitwise NOT are binary operators, which means they require 2 operands to perform calculations. Bitwise NOT is a unary operator. Let's look into the working of these operators. Bitwise AND produces 1 if both the bits are 1, otherwise it produces a 0. Here we are applying bitwise AND on 2 and 3. Binary representation of 2 is 0010 and binary representation of 3 is 0011. Applying bitwise AND produces 0010, which is equal to 2. Bitwise OR produces a 0 if both bits are 0. Otherwise, it produces a 1. Applying bitwise OR on 2 and 3 will give us 0011, which is equal to 3. Bitwise XOR produces a 1 if both bits are different and 0 in all the other cases. Applying bitwise XOR on 2 and 3 will give us 0001, which is equal to 1. Bitwise NOT just flips or inverts all the bits. Applying bitwise NOT on 2 will give us 1101, which is equal to -3. Right shift and left shift operators just shift the bits to right or left respectively by a given number of bits. While doing this operation, we keep dropping the bits from the end towards which we are moving and keep inserting zeros on the other end. So, applying a single right shift on 5, that is 0101, gives us 0010, whereas applying a single left shift on 5 gives us 1010. If you will look carefully, you will realize that shifting to right by every bit is equivalent to integer division by 2. This is why we get 0010, which is equal to decimal number 2 when we apply right shift to 5. On the other hand, shifting to left by every bit is equivalent to multiplication by 2, and we get 10 when we apply left shift on 5. In this video, we covered all the concepts related to bitwise operators. In the next few videos, we will discuss some interview questions related to bitwise operators. If you have any doubts, then leave them in the comments below or ping me on my Instagram handle, that is 10xcoder. See you in the next video.